So continuing the last part of motion in 2D, a machine gun is mounted on the top of a tower which is 100-meter high. At what angle should the gun be inclined to cover a maximum range of firing on the ground below? So you can think that if the angle is very low, let's say the angle is like this, then the bullet will just fall like this, and if angle is very high like this, then also it will go like this and then fall like this. So in between this angle and this angle, there has to be some angle where the range is maximum. So that's what he's asking, at what angle should the gun be inclined to cover a maximum range of firing on the ground below. Muzzle speed of the bullet is 150 meter per second. Muzzle speed is nothing but speed of the bullet relative to the machine gun, and since machine gun is mounted here, the muzzle speed of the bullet is actual speed of the bullet. It is 150 meter per second. Take G is equal to 10. So let's assume it is theta, which we want to know, at which the range is maximum. So what we'll do in this question is we'll find the range x in terms of theta. Then we'll see that how when theta is varying, x will be varying. So when we'll do dx by d theta, wherever we will get the dx by d theta is 0, that will either be the maximum range or it will be the minimum range. So by putting those values, we will find that where we get the maximum range. So our primary objective is to get x in terms of theta. So now it is given, it is 150 meter per second. So its horizontal component is 150 cos theta and vertical component is 150 sin theta. So again we can think of it in two parts as vertical and horizontal. So for the horizontal part, we can simply say that horizontal speed times time taken to fall is equal to x. So x is equal to 150 cos theta into t. For vertical motion, the time period will be same for it to fall down. So from equation of motion, again we can write s equal to ut plus half at square. S displacement is in this direction and we are taking upwards as positive. So it will be minus 100 is equal to 150 sin theta into t. Acceleration is again in negative, so minus half gt square. So we have two equations, and so what we need to find is x in terms of theta. So there is one extra variable t in these two equations. So let's remove t from the two equations, then we will get x in terms of theta. Solving this, we'll get this. Just replacing t here, so we'll get minus 100 is equal to this. This is a quadratic equation which will have two roots, and once you find those roots, that will come as function of theta. And when you will do that dx by d theta, so derivative of with respect to theta for this function of theta, wherever you will get 0, that is where x will be maximum and minimum. We will not solve it, it is quite complicated doing the differentiation of this function theta, but you understand the fundamentals that what we are trying to achieve here. Now this is a very interesting question. A fighter plane flying horizontally at an altitude of 1.5 km at a constant speed of 720 km per hour passes directly overhead an anti-aircraft gun. At what angle from the vertical should the gun be fired for the shell with muzzle speed 600 meter per second to hit the plane? At what minimum altitude should the pilot fly the plane to avoid being hit? So what is given is, at time t is equal to 0, the plane is directly above the gun. So what happens if the gun is aimed at the plane and fired? By the time the shell reaches here, the plane will be somewhere forward. So in order to hit the plane, the horizontal velocity of gun and plane have to be same, because then when the shell is here, plane will be here. When the shell is here, plane will be here. When the shell is here, then plane will be here and it will hit the plane. If the horizontal velocity of the shell is not same as that of the plane, then either the shell will always be ahead of the plane or it always will be behind the plane. Only when they are equal, then the shell will always be directly below the plane and at some point it will hit the plane. So it doesn't matter at what speed, what height the plane is flying. Even if the plane is flying here and the shell needs to hit the plane, even then the horizontal velocity of the bullet and of the plane have to be same. So now in our question, at what angle from the vertical should the gun be fired? Let's say that angle is alpha, which we are supposed to find. This is complementary angle 90 minus alpha. Let's call it theta. So we since we already know the equations for this angle theta, it will be easier for us for calculations. And the speed of the bullet of the shell is 600 meter per second. So again, breaking it into components, ux will be 600 cos theta and uy will be 600 sin theta. Height between the plane and the gun is given as 1.5 kilometers. So we already discussed why the horizontal component of this shell and the plane have to be similar. So we can say that 720 km per hour is equal to 600 cos theta. But here the units are different. This is kilometer per hour and this is meter per second. So we need to convert this into meter per second. So we can say 600 cos theta is equal to 200. 720 km per hour can be written as 200 meter per second. So 600 cos theta is equal to 200 meter per second. This gives us theta is equal to 200 by 600 is equal to 1 by 3. So theta is equal to cos inverse 1 by 3. So alpha, which we are supposed to find, is pi by 2 minus cos inverse 1 by 3. Now at what minimum altitude, so at what minimum altitude should the pilot fly the plane to avoid being hit? So pilot is flying somewhere above the gun at t is equal to 0, and so he's saying that at what height the plane should be in order to avoid getting hit by the gun. So one thing is constant, that is the angle alpha. If the gun wants to hit the plane, then this angle has to be alpha has to be cos inverse. Actually this should be, so alpha should be 90 minus cos inverse 1 by 3. So this angle is constant regardless of the height of the plane. So even if the plane is here, the gun has to hit at this alpha angle from the vertical. Even if plane is somewhere here, the angle has to be same. But if the plane is flying higher at this height, then it doesn't matter what is the whatever angle the gun has to be mounted, the plane will never be hit. Actually the angle has to be this alpha only, but at alpha angle this is the maximum height the shell can reach. So if plane is above this height, then it cannot be hit. So for maximum height we already have the formula for the height of the projectile, which is u square sin square theta by 2g. So here theta is again 90 minus cos inverse 1 by 3. So sin square of this will be cos square of this, so it will be 1 by 3. So square will be 1 by 9. So this can be written as 600 square 1 minus 1 by 9 by 20, which is 16,000. So this implies that alpha is 90 minus 1 by 3. So next problem is, the ceiling of a long hall is 25 meter high. What is the maximum horizontal distance that a ball thrown with a speed of 40 meter per second can go without hitting the ceiling of the wall? G is equal to 9.8. So someone is throwing a ball from here and the ceiling is 25 meter high. So you can throw it at any angle. Now question is, what is the maximum horizontal distance that ball can be thrown with a speed of 40 meter per second? So we already know that a ball is thrown at maximum distance when it is at 45 degree. But here when it is being thrown at 45 degree, it might hit the ceiling. First let us see that if what happens at theta is equal to 45 degree. So if at 45 degree its maximum height is less than 25 meter, then the maximum range covered will be what the range is at theta is equal to 45 degree. So for our range, the formula is u square sin square 2 theta by g. So let's find the height when the theta is 45 degree. So it will be u square sine square 45 degree by 2g, which is equal to 40 square by 20, and sine 45 degree is 1 by root 2, so 1 by root 2 whole square. So this comes out to be 40 meter. So clearly if it is thrown at 45 degree, then it will go something like this. So your range will be maximum, but this maximum height will be 40 degree. So this angle 45 degree is not correct. So it has to be less than 45 degree. So whatever that angle is, at that angle it will just about touch the ceiling and then go like this. Because up to 45 degree the range increases, and then 45 degree onwards the range decreases. So this is the maximum range. So the range now steadily decreases as you go down. So at whatever angle it just touches the ceiling, that will give you the maximum range which is possible in this hallway. So what we know now is height of the projectile is 25 meter. So we also know the formula for height for a projectile. It is u square sine square theta by 2g, which is equal to 25. So solving this, we'll get theta naught is equal to root 5 by 4. Therefore range is u square sine 2 theta naught by g. So we know sine theta naught, so we already know u square and g, so we can find range equal to u square. So it will be some calculation here, because sine 2 theta you need to write as 2 sine theta cos theta. Sine theta you can write directly, and cos theta has to be under root of 1 minus sine square theta. So solving all that, you will get the final range. A cricketer can throw a ball to a maximum horizontal distance of 100 meter. How much high above the ground can the cricketer throw the same ball? So again, in this case also, maximum range happens when theta is equal to 45 degree. So when you can throw that maximum range, maximum horizontal distance, that is 100 meters. So at maximum range, the range is u square by g, because sine square to sine 2 theta becomes 1. So this is u square by g, which is given as 100. How much above the ground can the cricketer can throw the ball? So it can only happen when the cricketer is throwing the ball vertically up. So when it is vertically up, then the range is u square by 2g. So this is half of the maximum range. So it comes out to be 50 meter. A particle is moving in a plane with a velocity given by u is equal to u naught I cap plus omega a cos theta. This is basically what is velocity which is given for a particle. So it's dependent on time. So there is some acceleration involved. So I and j are unit vectors along x and y. If the particle is at origin at t is equal to 0, then determine the trajectory of the particle, and b its distance from the origin at that time t is equal to 3 pi by 2 omega. So for the trajectory, it's basically a relation between x and y coordinates. So we are given u is equal to this thing, so we can say dx by dt is equal to u and u naught, and dy by dt is equal to omega a cos omega t. So integration of this will give you x is equal to u naught t, and integration of this will give you y is equal to a sin omega t. So you can see it that this will be cos omega t integration will be 1 by omega sin omega t. So 1 by omega, so omega will get cancelled and it will remain a sin omega t. So now we have a relation between x and t and y and t, and for trajectory we need to remove the variable t from both the equations. This will give us y is equal to a sin omega x by u naught. So this is our equation of trajectory. B its distance from the origin at time t is equal to 3 pi by 2 omega. So if we know the x and y coordinates of the particle at t is equal to 3 pi by 2 omega, we'll know its final location, and we already know its initial location, that is origin. So we will know the distance traveled by the particle, which will be under root of x square plus y square. So at 3 pi by 2 omega, what is x? X is u naught times 3 pi by 2 omega. What is y? Y is equal to a sin omega times 3 pi by 2 omega. So omega gets cancelled out, and sine of 3 pi by 2 is minus 1. So this is y is minus a. So if this is your coordinates, then x will be positive and y will be negative. So it is somewhere here particle at t is equal to 3 pi by 2 omega, and at t is equal to 0 the particle was somewhere here. So this gives us the distance traveled will be under root of x square plus y square. That will be our answer. The trajectory of a projectile in a vertical plane is y is equal to ax minus bx square, where a and b are constants and x and y respectively the horizontal and vertical distances of the projectile from the point of projection. Find the maximum height attained by it and the angle of projection from the horizontal. So this is the equation of the trajectory, and what we are supposed to find is the maximum height attained and the angle of projection from the horizontal. So maximum height is attained when dy by dx equal to 0. So that time it will be a flat curve. So if this is y versus x, then whenever it is at the top, that time we say slope is 0, that is dy by dx is 0. So at maximum height dy by dx is 0. So we will differentiate this, we will get a minus b 2bx is equal to 0, which gives us x is equal to a by 2b. So at x is equal to a by 2b we have maximum height, and that height is, just replace the value of x here, you will get the value of y at that x. Solving this, you will get y is equal to a square by ub. Now for and the angle of projection from the horizontal. So if that angle of projection is theta, and we know that maximum height is h, but this is not an equation of your normal trajectory. So this is not a kind of projectile, so we cannot use our formulas which we used for the projectiles here. So this is just a path of a particle which follows this equation. So if you remember, in the trajectory of the projectile there are terms of tan theta and all, so they are not there, so this is not a case of projectile. This is a normal problem without a ball being thrown at an angle. So let's say the angle of projection is theta. So what is that theta? It is dy by dx at origin. So we will say tan theta is dy by dx. And what is dy by dx? A minus 2bx. So at x is equal to 0 and y is equal to 0, that tan theta is the angle of projection. So let's put x and y 0 here. So we'll get tan theta is equal to a. That means angle of projection theta is tan inverse of a. So once more, if this is the y and x trajectory, then dy by dx is 0 at the maximum height, and dy by dx at x and y is equal to 0 will give you tan theta. And how do we know dy by dx at x and y is equal to 0? When we differentiate this, we get dy by dx is equal to a minus 2bx, and a minus 2bx is tan theta basically at any point. At highest point it is 0. At this point we will get the value of tan theta when we put x and y as 0. So when we put x and y as 0, there is no term of y here, so only x we will put as 0, and we will get tan theta is equal to a, which will give us theta is equal to tan inverse a. So that's the end of this chapter. Next one will do Newton's laws of motion.